So, okay, students, let us start the today's session, signals and systems. And now the topic is, yesterday we completed the introduction. So what is a signal and what is the system and classification of the system. Okay. So today's topic is signals and systems introduction and orthogonality. So myself, it is Vijay Shankar from EC Department, Civil Engineering College. Okay. See, yesterday we learn what is the signal and what is the system. So once again, I will explain what is the definition of signal and the definition of system. What is a signal means a function of one or more independent variables. A function of one or more independent variables which contain some information. So what is that one variable and the two variable and more variables means? So when the output function in with a variable of a single variable x, we can call it as a one variable or one dimensional, and output response in the two variables, it is a two variable or two dimensional function, and having the three variable function or the three dimensional. Okay. And the examples are the electric signals and non-electrical signals. Electric signals are the radio signals, the TV signals, and the telephone signals. And non-electrical signals, I already told, pressure signal and the sound signals. Okay. And coming to the system, it is a set of elements. It is a set of elements or functional block diagrams. The functional blocks connected together and produces an output in response to the input signal. Okay. Once again, I am saying it is what is a system definition means. It is a set of elements or functional blocks that are interconnected together or connected together and produces an output in response to the input signal. My students. Okay. So what is the example for this one? The audio amplifier and attenuators and TV sets and transmitters, receivers, etc. So these are the examples of the system. So the block diagram saying that taking the input signal, very low audio signal is given to the audio amplifier, and this amplifier is nothing but a system. It performs the operation. It performs the operation on the input signal. It performs the operation on the input signal. What we given here, that given signal is a very low signal. Okay, very low signal. It performs the operation on that signal by the system, nothing but it's an amplifier, audio amplifier. It gives a response, nothing but it's an output signal. It gives a response, nothing but output signal, that is amplified audio signal. Whatever the given low level audio signal is strengthened by using the audio amplifier as a system to get it is a increased level. That we discussed in the previous class, the last class. Okay. Now, you can go for the next topic, that is nothing but orthogonality. Okay. You see the orthogonality. Before that also, there is a two types of signals we already discussed in the previous class. That is continuous time signal or the continuous signal and discrete time signal. Continuous time signal is defined as for every instant of time. For every instant of time is nothing but a continuous time signal. At particular instant of time, the discrete time signal is defined as at a particular instant of time. Particular instant of time is nothing but a discrete time signal. How we convert the continuous to the discrete time means by after sampling we'll get the continuous signal to the discrete time signal or discrete signal. And this discrete signal is again converted to the digital signal by using the quantization. After the quantization, it is converted to the digital signal. Means both the amplitude and the time is discrete. We can call it as a digital signal. We can call it as a digital signal, my dear students. Okay. And what is a continuous time signal is nothing but the amplitude is continuous and the time is also continuous. Amplitude is continuous and time is also continuous. Understood? And discrete time signal means the time is discrete and amplitude is a continuous. Means by sampling the time with the 0.5 and the 1 or the 2, the continuous signal is converted to the discrete time signal. And this discrete time signal is amplitude is continuous and time is a discrete. Yesterday I showed that in the graphical representation also by using the characteristics. Okay. The x-axis is the time and the y-axis we are taking as a signal. That signal is x of t. The t is varies, correspondingly x of t is also varies. Understood, my students? Now you can see here the orthogonality. So today's topic is the orthogonality concept in vectors. The orthogonality in signals we have, and orthogonality in the approximation signal, and orthonormal signal also we have. The first topic in the orthogonal or orthogonality. Using the vectors. Suppose we can take two signals, the two vectors. The two vectors we can take, the two vectors are x and the f. You see in this graphic, in the diagram, the orthogonality concept in the vectors, The x is in the x-axis, f is in the y-axis actually. So what is orthogonal means? Orthogonal means mutually perpendicular to each other. Perpendicular. Perpendicular is nothing but f is a vector, x is a vector. These two vectors are perpendicular to each other. Then we can say those two vectors are orthogonal. Those two vectors are orthogonal. Okay, my dear students. See how we can find the orthogonal mathematical equation to find out whether these two are orthogonal or not. See, the orthogonal, all signals are basically vectors, where vector is represented as a terms of its coordinates. So what is a vector? We know the vector having the magnitude and also the direction. Okay, scalar means having only the magnitude, there is no any direction. Following my dear students. Vector means it having the magnitude and also the direction. Scalar means it having only the magnitude, it does not having any direction. We can call it as a vector, scalar. Following my dear students. See, consider a vector f and another vector x. You see here, in the orthogonality concept in the vectors, what I shared here, where another vector is x, then the projection of vector along other vector is shown in the below. Okay, the projection. So what is that projection? See, there is a angle between of x and f. There is an angle between x and f. That angle is a theta. Now what I am showing here, and f vector and x vector is not orthogonal because they are not in the perpendicular to each other. And in between there is an angle is there, that angle is a theta. Following my dear students. In between there is an angle is there between of x vector and the f vector. To find out and mathematical expression to convert this as a vectors in orthogonality, the equation. Now I'm draw a perpendicular line. You can see here one line is there. In your phone you can maximize the diagram and then you can see a perpendicular line is drawn from here. I am using from f vector to the x vector. Okay, and on the vector x, the point is on the vector x, the point is cx. Following. And after drawing a perpendicular line from the f and the x represented as E and the direction is upwards, a point on the x vector is a cx. Okay, a point on the vector is a cx, my dear students. Now it shows like a right angle triangle. It shows a right angle triangle. Hypotenuse is a f and adjacent side is a cx and opposite side is a E. Follow my dear students. Let us assume that it is a right angle triangle. Hypotenuse is a f vector. Okay. And adjacent side for the theta we have. Adjacent side we have the theta is there. That adjacent side, the distance is a cx. The distance is a cx. And opposite side, what we drawn a line perpendicular for the vector of f and the vector of x, and the direction is upwards. and that is E. Opposite side is a E. We know what is a cos theta? Cos theta is equal to opposite side by hypotenuse. What is the opposite side here? E is opposite side and hypotenuse is a F. Following my students. So cos theta is equal to E by F. And another we have to know the equation also. Hypotenuse is equal to side plus side. Hypotenuse is equal to side plus side. See the last equation in this page using vector addition. F is equal to, F is nothing but, you see here the F is nothing but hypotenuse. According to the right angle triangle, hypotenuse is equal to side plus side. One side is a CX, another side is a E. What is that E is represented as? What is that E is represented as? Error vector. Error vector. Understood? Why it is that error? Because there is an angle of theta we have and the F and X is not perpendicular. There is an error is there. That is a E, error vector, nothing but. After converting this theta as 90 degrees, then only the F and X are orthogonal to each other. Okay. I'm using this equation, F is equal to Cx plus E, that F is hypotenuse and Cx is a side and E is another side. Following my students. Okay. Then we know the dot product, the vector dot product. Vector dot product formula is F dot X is equal to, F is one of the vector and the X is the another vector. What is the formula for the dot product of the two vectors means, you know that is we'll get in the mathematics the dot and the curl functions. Okay, the divergence and the curl. Divergence is nothing but the dot. The dot product is the magnitude of F vector and the magnitude of X into cos theta. That is a formula for the dot product of the two vectors. Okay, what is the two vectors we have? The F and the X. If suppose those two vectors are the cross product, what is a cross product? We know, my dear students, everybody know that it is a cross product of F cross X is equal to the same, the magnitude of F, magnitude of X, sine theta. When we have getting the sine theta, we can apply the cross product of the two vectors, F and X. But here I'm applying dot product. Dot is nothing but divergence. Okay, the dot product. In that dot product, F dot X is equal to magnitude of vector F and magnitude of X and cos theta. Following my dear students. Now let us see to find that error vector. I'm going to the next page. You see here, the E is a minimum. E is the minimum only when it is a perpendicular to X. Below the shown the figures which is not perpendicular. I drawn these two lines here. I drawn the two lines. See, you can maximize your screen. Then you can visible this. I taken is a C1 of X, and there is an error is a E1. Okay, and another point I am taking here C2X. The error is a E2. So I place one time with the C1X is the distance from the origin. I place the another point on the X, C2X. So what I have told in the previously, it is not the perpendicular line. You can draw the F from X. I'm changing this C1X and the C2X also. And before that perpendicular line and after that perpendicular line. Okay, what I shown You see here, in this, the error signal what we got, here, that is a Cx. So I move this Cx towards negative minus infinite and move towards positive value. Okay, then we'll get C1x and the C2x, my dear students. So see, here the C1x and the C2x, what I am saying here, the component of f along x is a Cx, which is given by the cos theta. What is the cos theta? Adjacent side, that is nothing but Cx, and by the hypotenuse. What is the hypotenuse saying? That is a f. So Cx by the f is equal to cos theta. And taking that is a magnitude on both sides. See, the C magnitude of x is equal to magnitude of f cos theta only, my dear students. That is a formula we got. C magnitude of x is equal to magnitude of f cos theta means cos theta is equal to adjacent side. What is the distance of that adjacent side here? Cx. What is the hypotenuse here? F. I'm taking the magnitude of that C and x. C is the fixed variable. Okay, it's not the variable, it's a fixed value. And x is varying and the f is varying because it is also, those two are the vectors. So I'm taking the vector for the magnitude for the x of vector and magnitude for the f vector. So C magnitude of x is equal to magnitude of f cos theta. So for this equation, I am multiplying both sides the magnitude of x. You see in the next line, multiplying both sides by magnitude of x. Then it becomes of C, one magnitude of x is already there. Now I am multiplying with another magnitude of x. That becomes of squared magnitude of x is equal to, in the right hand side, the magnitude of f, magnitude of x cos theta. Following? And how is this got Cx by f after cross multiplying the f cos theta is equal to Cx, my dear students. Don't confuse that. So after multiplying the magnitude of x on both sides, C squared magnitude of x is equal to magnitude of x and magnitude of f cos theta. Rubina, don't write anything on the screen. So now you can see in the right hand side the magnitude of f, magnitude of x cos theta. That is a formula. It is dot product of the two vectors. Dot product of two vectors. So I replace that magnitude of f, magnitude of x cos theta as f dot x. So the equation becomes C, the squared magnitude of x is equal to f dot x. From this equation, I'm taking the C is equal to f dot x by the squared magnitude. F dot x by the squared magnitude. Following, my dear students, that C is equal to, that C, when the C is equal to 0, when C is equal to 0, f and x both are orthogonal. When we again move that C towards the right side, there is a changes of the angle between of vector f and the vector x, and those two vectors are not orthogonal. Why it is, you can see. I'm saying the C is equal to 0. Whenever the C is equal to 0, then only those two are orthogonal, nothing but mutually perpendicular to each other. I am saying how it is also. You see, the C is equal to f dot x is by the denominator magnitude of x square. What is a f dot x? Nothing but magnitude of f, magnitude of x, and cos theta. Okay, that theta is 90 degrees, then only it becomes of orthogonal. What is a cos 90 degrees? The theta is 90 degrees, then only those two are mutually perpendicular to each other. Mutually perpendicular to each other. So cos theta, the theta is 90 degrees, cos 90, nothing but 0. Cos 90 is a 0. If numerator is a 0 and the denominator, the squared magnitude of x, whatever the 0 by anything is nothing but the 0. C is equal to 0, my dear students. If C is equal to 0, then the vector f, the vector x, both are mutually perpendicular to each other or are orthogonal to the each other. Following. Otherwise, other than the theta 90 degrees, suppose it can take is a cos theta, the theta is 30 degrees or 60 degrees or 0 degrees also. Cos 0 is a 1, but C is not becomes of the 0. When C is equal to 0, then only the both vectors f and x are orthogonal. Understood, my dear students? Then only it becomes of C is equal to 0 like here. See, again you can see the about two diagrams, C1x here, the C2x. That C, when it becomes moves towards origin, then only the f and x is both are orthogonal. If you can move the C towards the right side as a C1 and the C2 and C3 and so on, the values, the f and x are not orthogonal because there is an angle theta is there that is not 90 degrees. Following, you can see here, when f is perpendicular to x, f will not have component along x. F will not have component along x. What is that component? That E. When there is an angle is theta is equal to other than the 90 degrees, definitely there is another component is there. That component is an error component E. When f is perpendicular to x, f will not have component along x because theta is a 90 degrees. Because theta is a 90 degrees as shown here, the f and x, theta is 90 degrees, that Cx is equal to 0. Cx is equal to 0, my dear students. That f dot of x is equal to, we have the formula is there, magnitude of x, magnitude of f, cos theta, that theta is 90 degrees, then only the f dot x becomes a 0. If f dot x is equal to 0, then the C is equal to 0 because it having the formula is a C is equal to f dot x by the magnitude of x square. Understood, my dear students? Then finally seeing that the vector f and x are said to be orthogonal. F and the vectors f and x are said to be orthogonal if their dot product is 0. If their dot product is 0, then only the f and x are orthogonal or mutually perpendicular. See here, the vectors f and x are said to be orthogonal if their dot product is 0 or the vectors are orthogonal if they are mutually perpendicular. The f and x are mutually perpendicular. Nothing but it is a 90 degrees. Following, my dear students. What is the formula here? We got, we derived the formula to get the vectors as mutually perpendicular or the orthogonal. C is equal to f dot x by the squared magnitude of x. See here, the denominator having the squared magnitude is nothing but it is not at all equal to the 0. Then only it satisfies that condition. It is not at all equal to the 0. If it is a 0 means definitely it becomes of infinite. C is infinite means f and x is not orthogonal. Okay. C is infinite means f and x vectors are not orthogonal. F and x is orthogonal when the C is equal to 0 only. What is that C? That is a point only. The point on the x. We are moving from origin to the infinite as a naming of C1x, C2x like that. Totally the C is equal to C1 plus C2 plus C3. Okay, we are taking only one point. Understood? So I hope everybody understood this, understand the orthogonality of concept of the vectors. Then you can go for the next topic of the same orthogonality, but it is not in the vectors, in signals. Orthogonality in signals. So what is a signal now? We can represent it as f of t. Previously, we have not represented the f of t because the vector it is not varying with respect to the time. And another signal is there. That signal is x of t. There we are taking that one vector is f, another vector is a x. But here one signal is f of t, another signal is a x of t. And the intervals in between of t1 and the t2. t1 and t2. Okay, now you can see how we can derive this orthogonality in signal equation. Okay. Here also I am taking the x-axis is x of t, the signal, and y-axis the signal f of t, and the angle between of f of t signal and x of t signal is 90 degrees. Then both the signals f of t and x of t are orthogonal. Both the signals are f of t and x of t are orthogonal. Okay. Otherwise, f of t and x of t signals are not orthogonal. Why? Whatever the c, if I am taking here, that c is moves towards the right side to the infinite, it becomes of c1, c2 and like that. Then the f of t and x of t is not mutually perpendicular to each other. So let us see here in this slide, the first equation saying that f of t means hypotenuse. Following my dear students, of hypotenuse, and there is a theta is there because it is not mutually perpendicular. You have to draw one perpendicular line E as E of t now because it is a signal, and x of t is x-axis because it is a signal, we are represented as x of t, and f of t is also the signal, but it is in the hypotenuse. Hypotenuse is equal to side. One side is the c x of t, another side is E of t. Following my dear students. Previously we taken as a vector. So the vector is represented as f is equal to cx plus E. But here It's not vector, it is the signal. The signal is always represented with respect to the time. With respect to the time, f of t, x of t, e of t. E of t here also error signal. There error vector. Alright. So according to the right angle triangle, hypotenuse is equal to side plus side. Now I am taking the E of t is equal to f of t minus c into x of t. E of t is equal to f of t minus c into x of t. The t is varies from the t1 and the t2. That is finite duration, or otherwise the t is varies from minus infinite to infinite actually. You can take it as minus infinite to infinite always. Otherwise, the T1 and the T2 is in between of minus infinite to infinite only. Okay. So before going to derive this equation, you have to know energy signal. What is the energy signal? Energy signal is nothing but the signal E. I wrote here E suffix E, capital E, and suffix E, small e. That is error energy signal. Error energy signal. So it is a continuous time signal, x of t or f of t or the e of t. Discrete means yesterday we discussed discrete is represented as x of n, f of n, and e of n. N is also variable, t is also variable, but n is denoted in the discrete time signals and t is denoted in the continuous time signal. This is a continuous one. Following E suffix E, error energy signal is equal to. So what is the error signal here? E of t. E of t is the error signal. So since it is in the continuous time signal, we can take as an interval the integral of initial value is t1 and the t2, or otherwise you can represent it as a minus infinite to infinite also. That is a finite duration, and this one is a infinite duration. Not infinite. Infinite duration is minus infinite to infinite, and this is finite duration t1 to t2. The formula is error energy signal is equal to the integral of t1 to t2. You see here, t1 to t2 e square of t dt. Because it is with respect to the time varying error signal. This is a formula for the energy signal. Energy signal. Energy can neither be created nor be destroyed. That only I say that in the orthogonality concept of vectors also, the denominator is not at all equal to the zero. That is squared magnitude of x. That is nothing but energy signal only there. You'll get now here. The energy signal that varies from t1 to t2, the e square of t dt. Remember this one. Okay. Before that, we have there is a mean square value is there. That is also one of the formula. The mean square means the e square of t 1 by t2 minus t1. Forget about this equation. We'll get in the next topic. It is mean square value of e of t. Okay. From equation 1, you can see here in the below, from equation 1, we can write it as E is equal to integral T1 to T2. What is the E of T? You see the equation 1 here? Equation 1. In this equation 1, E of T is equal to F of T minus C into X of T. You see here. The error signal from the right angle triangle, hypotenuse is equal to side plus side. That error signal one side is equal to hypotenuse minus another side, f of t minus c into x of t, my dear students. That I replace here as e of t. So f of t minus c into x of t whole square. Okay, and this is the error energy signal. To get the equation of orthogonality in signals, we can apply the derivative with respect to the c. We can apply the derivative of first derivative. first derivative of the error energy signal with respect to the C. Following. Here the value of C should be selected such that E will be minimum. When it is a minimum, this can be obtained by the differentiating E with respect to the C and equate to the 0 for the minimum value. To get the C as a minimum value, my students. See the dE by the dC is equal to 0. What is the D here? Differentiation. The differentiation we are applying for the error energy signal with respect to the C. Okay, with respect to the C. Now I am applying the first derivative. What is that first derivative here? The d by dC of, what is the formula for the a minus b whole square? A square minus 2ab plus b square. And you can split the integrals also the three terms. The first term is d by dC of integral t1 to t2 a square. What is the a here? F of t. So f square of t dt. And d by dC of minus 2ab, the integral t1 to t2, 2ab. What is it? 2a is f of t and b is c into x of t. So 2c f of t x of t dt. And the third term is d by dC of integral t1 to t2 c square x square of t dt is equal to 0. We got the three terms with respect to the C and having the integral also. Following, how we got these three terms? Because the error signal E of t is having the formula for f of t minus c into x of t. This will get from the right angle triangle. Following, my dear students. So now you can see it is independent of C here, the first term. Because we are applying with respect to the C is a constant. Definitely that becomes of the 0. Okay. And in the second term, you can see the C is there. In the second term, we are applying the first derivative with respect to the C. So derivative of C with respect to the C is 1. Derivative of C square with respect to the C is 2C. Okay. In the second and the third terms, both having the C value. So for the first term is a 0 here. I'm not wrote here the 0 because of it is independent of the C, my dear students. There is no any C term. So applying the derivative with the constant is always a 0. Minus 2, C becomes of 1, f of t x of t dt. Plus C square is here. The remaining all it is a constant only. C square. We are applying the d by dC of C square. D by dC of C square is at 2C. The integral t1 to t2 x square of t dt is equal to 0. Now, in these two terms, in the right hand side is a 0. One term is a negative sign and another term is a positive. Now it becomes of bring that negative to the towards the right side as of 2C. 2C, the integral t1 to t2 x square of t dt is equal to 2 into integral t1 to t2 f of t minus x of t dt. Not the minus here, into only, dot. Following, my dear students. So f of t into x of t dt. So on both sides we have 2. Cancel that 2 here. And C is equal to, now I can write as a C is equal to integral t1 to t2, integral t1 to t2, f of t x of t dt is in the numerator, and C the denominator as integral t1 to t2 x square of t dt. That is an energy signal equation. But this energy signal is not the error energy signal. This is an input energy signal. What is the input here? X of t. So E suffix x. We see here the E suffix E I wrote So e as e square of t. If suppose e suffix x is there, integral t1 to t2, it becomes of x square of t. If suppose e suffix f is there, f, integral t1 to t2, f square of t dt. Understood, my dear students? So the denominator what we got here for the c is equal to, okay, the c is equal to, that is the energy signal formulae. It is not at all equal to the zero because the energy is not created, neither be created nor be destroyed. So the denominator is not at all equal to the zero. To get the c is equal to 0, only the numerator is a 0. Then only the c is equal to 0. When these two signals are orthogonal, the integral t1 to t2, f of t into x of t dt is equal to 0, then only the c is equal to 0. Because the numerator term is integral t1 to t2, f of t, x of t. Okay. Denominator is not at all equal to 0 because it is energy signal, my dear students. In the vector also we got f dot x, that f dot x is equal to 0, then only the c is equal to 0 there. How that f dot x is equal to 0? The theta becomes 90 degrees. Theta becomes 90 degrees. Okay. And now the equation for the orthogonality in signals is c is equal to integral t1 to t2, f of t, x of t, dt by the integral t1 to t2, x square of t dt. This is the equation of orthogonality in signal. To satisfy this orthogonality, nothing but mutually perpendicular to each other of f of t, x of t means the integral t1 to t2, f of t, x of t dt is equal to 0. Nothing but is a numerator. Numerator becomes a 0, then only the c is equal to 0, my dear students. Understood? So these are one concept, orthogonality in signals. Today we learn the two concepts in the orthogonality, the orthogonal in vectors and orthogonal in signals. What is the formula we got? The orthogonal in vectors means c is equal to, nothing but c is a capital C there. C is equal to f dot x by squared magnitude of x square. When it becomes of c is equal to 0, f dot x is equal to 0. When this f dot x is equal to 0, theta is equal to 90 degrees. If theta is 90 degrees means the f vector and x vector are both orthogonal or mutually perpendicular to each other. Mutually perpendicular to each other. Understood? And coming to the orthogonal in signals, here we are taking one signal is f of t, another signal is x of t. If these two are mutually perpendicular to each other, in between the angle is a 90 degrees. There is no any component of f of t and x of t. When we'll get the component of f of t and x of t, the theta is not 90 degrees, then there is an error signal will get e of t. That is nothing but component of f of t on x of t. So that error we got e of t. That error we got e of t, and adjacent side we have the c into x of t, hypotenuse f of t. According to the right angle triangle, f of t is equal to one side, that is a c into x of t, another side is e of t. We're adding these two, f of t is equal to c into x of t plus e of t. C into x of t plus e of t. Okay. And that from that equation, you can take that e of t is equal to error signal e of t is equal to f of t minus c into x of t. F of t minus c into x of t. Understood? Now we know the energy signal equation, error energy signal equation. E suffix E, capital E suffix small e is equal to integral. It is either finite duration T1 to T2 or infinite duration is also both are the same, my dear students. Both are not the same actually. We can take it also infinite duration. We can take it also finite duration. Now we can take the finite duration here. Integral T1 to T2. Integral T1 to T2 e square of t dt, because we are taking the suffix is e. If suffix is x, x square of t dt. If suffix is y, y square of t dt. If suffix is f, integral t1 to t2, f square of t dt. Following? Now I can substitute the e of t as f of t minus e into x of t in this equation and expand that. E suffix e is equal to integral t1 to t2 f square of t minus 2 c x of t f of t plus c square x square of t, because it is a minus b whole square is a square minus 2ab plus b square. To get it is a minimum value of c, we can apply the derivative with respect to the c and equate to the 0. And equate to the 0. Following? After applying the first derivative for the three terms, the first term it is independent of c, it becomes is a 0, and second term is having the c, with respect to the c will get the value 1. The third term is with respect to the c we are applying the derivative, c square becomes of 2c. C square becomes 2c. So first term is a 0, second term is minus 2 into integral t1 to t2 f of t x of t dt, and third term after applying the derivative plus 2c integral t1 to t2 x square of t dt is equal to 0. Now simplify this equation to get the c is equal to, capital C is equal to numerator integral t1 to t2 f of t x of t dt and denominator t1 to t2 x square of t dt, x square of t dt. When this equation is orthogonal, the signals f of t x of t means the numerator, whatever we have in the c equation, the numerator is a 0, then the signals, both signals are orthogonal. Means integral t1 to t2 f of t x of t dt is equal to 0. Then c becomes 0. Then we can say f of t x of t are mutually perpendicular to each other or orthogonal to each other. Understood, my students? Okay. And in tomorrow's class, the same topic we can take orthogonality only, but orthogonality in approximation signal and mean square value also. You see here the one mean square value I already wrote, that is a e square of t whole bar is equal to 1 by t2 minus t1 of error signal, t1 to t2 e square of t dt. You can use this formula to derive the equation of mean square value also. Orthogonality in approximation signal and mean square value in the tomorrow's class. Understood? You see now, there's so many students. So very good. Everybody log in with their roll numbers and the names. I not allowed, not admit the some of the students. They are writing something. They are writing something in the name itself. And tomorrow I have to see that everybody have to log in with name also. 477. There is no name here. And coming to Pavinisha N, no number. Karthik, no number. And Vani Sunkara, no number. And Srinivas, no number. Shravani, no number. Ram Prasad, no number. See, that is a discipline. What a word is given by the faculty members, you have to follow that, my dear students. Okay, you have to learn that. So in the tomorrow class, I hope everybody can log in with your number and the name. Don't write another things. And Amarnath also. No number for the Amarnath and the Karthik, Ram Prasad, Srinivas, yes, and Srinivas Rao B.Tech, and Vani Sunkara. These are the students not log in with their numbers. In the tomorrow class, with your number and the name is there only, I will admit. Following my students, I already told to all the persons how to log in with your number and the name. Even there is no any number, it is somewhat difficult to take the attendance to me. Understood? You are writing something is there. And 477 also, no name, 19, EC student. Okay. Ram Prasad also, still he is not changing his name, number, and Shravani, because they are not in the online. They're simply on the phone and chit-chatting anywhere. And Srinivas also. Don't use the 456 Harsha Pritam. Don't use fonts. You simply have to write the names simply. And still Shravani, Srinivas Rao and Vani not changing their Ram Prasad also. If they are either it's a triple E, I don't know, and they are from ECE students. And also another person is there, 480. So what is your name? 480, Darling Samba. Don't write those unnecessary names. Okay. You write your name only, don't write this darlings like this. Don't write up the shortcuts also. It is new to me to know your names and the numbers. Still is a Srinivas, Shravani, Srinivas, B.Tech and Vani Sunkara. They are not updating their names. Shravani number is 206. Strictly you are the third year, Shravani. You have to know the role model to the juniors. Very good. Whatever it is, Ram Prasad, 207. Very good. And still Vani Sunkara. And 480 also. Vani Sunkara. Change your name, number also. And 480. What is your name actually? 480. Don't put it as a drawings and something like that. Very good, my dear students. Hope everyone is understand what I said. The orthogonality concepts in vector and orthogonality concepts in the signals. So up to now, the tomorrow's yesterday's class and the today's class, we learned the topics is the definitions of a signal, definition of the system, and examples of the signal, examples of system, and the types of signals, and orthogonality concept. The two concepts we learn, vectors and signals. The formula is C is equal to f dot x by the square root magnitude of x square is an equation for the orthogonal of vector. Orthogonal in vector. Orthogonal concept in vector. And orthogonal in signals, the equation is C is equal to integral t1 to t2 f of t, integral t1 to t2 f of t, x of t dt, denominator the integral t1 to t2 x square of t dt. Okay. Thank you one and all, my dear students. Tomorrow I hope everyone can log in with your number and the name on. Understood? Still I don't know the name of 477, the EC student.
Venugopal, sir.
Okay, he's not logging with their name. Very good. Thank you, my dear students.